or the LCM. Okay, so that's what we're going to kind of go over first, is how to find an LCM before we can get a common denominator. Okay, so to add and subtract these rational expressions, you do need a common denominator. So just as with rational numbers in fractional form, to add or subtract two rational expressions that have unlike denominators, you must first find the least common denominator. Shh. Quiet and pay attention now. Okay, so you must first find the least common denominator. The least common denominator is the least common multiple, or LCM, of the denominators. To find the LCM of two or more numbers or polynomials, you need to factor them. The LCM contains each factor of the greatest number of times it appears as a factor. So with our numbers here, your LCM, you're looking at the denominators. Shh. You're looking at the denominators. So in this case, it'd be 6 and 9. Okay, so you're trying to find the LCM of 6 and 9. Well, 6 factors into 2 times 3, and 9 factors into 3 times 3. So what I do is I write the entire first factor, so 2 and 3. Okay, then I look at 9. Okay, well, I already have a 3, so I shouldn't include another one. But I need at least one more. Okay, because there's not 2 3s in 6. So I need that one more. So I have 2 times 3, or 18. For polynomials, again, you're just looking at the denominators. Okay, so I have x squared minus 3x plus 2. Okay, that factors into x minus 1, x minus 2. And I have 2x squared minus 2. That factors into 2 times x minus 1 times x plus 1. Now again, I write out the whole first one, the whole first factor. So x minus 1 and x minus 2. Okay, x minus 1, x minus 2, right here. Okay, now this 2 wasn't included in this one. So since I don't have it, I need to include it in the LCM. Okay, I already had an x minus 1, so I don't need another one. But I didn't have an x plus 1 from above, so I need to include that one as well. Okay, so that would be my LCM there. So we are going to practice this with a couple examples here. So we want to find the LCM of these three terms. Okay, so I need to factor 12a squared b. Okay, so I need the factors of 12. Okay, that's 2 and 6. Okay, so I have 2 times, now 6 factors into what? What does 6 factor into? What does 6 factor into? 2 and 3. Okay, so that's my factor of 12. Then I just include a squared and b. Okay, next term is 15abc. Okay, factors of 15. Shh, stop talking. Factors of 15 are 3 and 5. And then again, I need to include my variables. The last one is 8b cubed c to the 4th. Okay, factors of 8 would be 2 and 4, but I can also factor 4 into 2 times 2. Okay, so you're looking for the prime factors when you do this. Okay, then we have times b cubed and times c to the 4th. So now I do want to write out the LCM. So I'm going to start with just my numbers. Okay, I'm not going to include any variables yet. So I start with my whole first term. So I have 2 times 2 times 3. Okay, from there I look at my second term. Well, I already included a 3, so I don't need to write down another one. But I don't have a 5, so I should also write down a 5 here. So I multiply by 5. Okay, then move to the third term. I have a 2. Okay, I have another 2, but I don't have a third 2, so I need to include one more 2 in my number here. Okay, next I look at the variables, okay, my numbers here. I always look for my greatest exponent. Okay, so for the a's, my greatest exponent would be a squared. So I would have a squared. For b, the one that has the greatest exponent is b cubed. And then c, the greatest exponent is c to the 4th. Okay, so from here I can multiply all of my whole numbers together. Okay, when I do that, I get 120. And then my variables a squared, b cubed, and c to the 4th. So that would be the LCM of those 3 terms. Okay, questions on letter A? All right, then we're going to do the same thing in letter B, except this time they are polynomials. Okay, so our first term is 4a squared minus 12a minus 16. And I need to factor that. So first thing I notice is all 3 of those terms within that polynomial can be divided by 4. Okay, since I can divide each of those by 4, I'm going to factor out a 4 first. Okay, so if I factor out a 4, I'm left with a squared minus 3a minus 4. Now I can factor this further. Okay, to factor this, you can use the x method. So what adds to negative 3 and multiplies to negative 4? Adds to negative 3, multiplies to negative 4. 1 and negative 4. Okay, so this factors into 4 times the quantity, a minus 4 times a plus 1. Okay, so that was my first term, and I factored it. My second polynomial here is a cubed minus 9a squared plus 20a. Again, first thing I do is look to see if I can factor anything out of all 3 of those terms. You can factor out an a. Okay, so I'm going to factor out an a. Then I'm left with a squared minus 9a plus 20. And again, I can use the x method to factor what's inside those parentheses. Okay, so what adds to negative 9 and multiplies to positive 20? Negative 5 and negative 4. Okay, so this will factor into a times the quantity, a minus 5 times a minus 4. Okay, so now that I've factored each one, I want to write out the LCM. So to do that, I always take my first term that's factored and I just rewrite it. Okay, so I have 4 times a minus 4 times a plus 1. Then I look at my second factored term. Okay, I didn't just have an a from the first one, so I need an a. Okay, did I have an a minus 5 in the first one? Do I have an a minus 5 yet? No, so I need an a minus 5. Do I have an a minus 4? Yes, so I don't need to rewrite it. Okay, from here I'm going to make this look a little bit nicer. So I'm going to combine this 4 and this a. So I have 4a times my quantities a minus 4, a plus 1, and a minus 5. Okay, so that will be your LCM of those two polynomials. Okay, so all you're doing is factoring and then combining. Questions on letter B? So as with fractions, rational expressions must have common denominators in order to be added or subtracted. Okay, you need to get a common denominator. You cannot just combine the numerators. So in words, adding. To add rational expressions, find the least common denominator. Rewrite each expression with the least common denominator. Then you can add. Okay, so if I have a over b plus c over d, your least common denominator would be b times d. So to change here, this one still needs a d in the denominator and in the numerator. So I would change that to ad over bd. For c over d, I need to multiply both numerator and denominator by b. Okay, so here I have b over b added on there. Okay, so then you have this common denominator, and you can add your two numerators together. Okay, same thing with subtracting rational expressions. Okay, you need to have that least common denominator. So if I have a over b minus c over d, again I have a b and a d. So my least common denominator would be b times d. So I'd have to multiply my numerator and denominator by d. In my second fraction, I need to multiply by b over b, and then I can combine my numerators. Okay, so it's just like combining fractions. Questions on that before we do an example? All right, so example 2, we want to simplify 5a squared over 6b plus 9 over 14a squared b squared. Okay, so we need to find the LCM of our denominators just like we were doing on the front. Okay, so I'm going to take 6b and I'm going to factor it just like we did before. Okay, so the factors of 6 are 2 times 3, and then we also have a b. Okay, so factoring out that first denominator. Okay, we want to do the same thing with the second denominator. So 14a squared b squared. Factors of 14 are 2 and 7. Okay, and then we have an a squared and a b squared. Okay, so we're just finding the LCM like we did in the first two problems on the front. So again, I need to take all of my first one. Okay, so that's 2 times 3. I'll save the variables second. Okay, looking at my second term here, did I already have a 2? Yes, so I don't need to rewrite it. Do I have a 7 yet? No, so I need to multiply by 7. Okay, then looking at our variables, we have an a and a b. So we need to look at your greater exponent. So this one, your a is squared. Okay, I have a b and a b squared. Okay, since b squared is the greater exponent, that's the one I need to use. Okay, then I can multiply out front here. So 2 times 3 times 7 is 42. And then we have an a squared and b squared. Okay, so this is just helping us find that least common denominator. So I'm going to take my first whole fraction here of 5a squared over 6b. Now I need to change that 6b to make it look like 42a squared b squared. Okay, so what would I have to multiply into 6 to change it to 42? What do you have to multiply into 6 to make it 42? 7. Okay, so I need to multiply by 7. And then what do I need to multiply in to get an a squared in the denominator? A squared. And then I still need a b squared in the denominator as well. Right now I just have b, so I just multiply in a b. Okay, I'm going to do the same thing with the second fraction. Okay, so I have 9 over 14a squared b squared. And we want to multiply in whatever makes this 14 42. That'll be 3. Okay, so I need to multiply in 3. Now, in this denominator, I already have an a squared, so I don't need to multiply an a in. And I already have a b squared, so I don't need to multiply a b in. Okay, so now I'm just multiplying these fractions. So I can multiply my numerator straight across. We have 5 times 7 is 35. We have a squared times a squared. That's a to the 4th. And then we have it multiplied by b. Okay, now when I multiply my denominators together, I should end up with the LCM. So 6 times 7 is 42. We have an a squared, and then b times b is b squared. So I did end up with that LCM. Okay, same thing over here. Multiply your numerators. So we have 27 over 14 times 3 is 42. And then we have a squared, b squared. Okay, now I got this common denominator so that I could combine my two fractions. So I can just rewrite this as 35a to the 4th b plus 27 all over that same denominator of 42a squared, b squared. Questions? No questions? So again, first step is to find your LCM. Second step is to multiply by a version of 1, so multiply to the numerator and denominator by whatever you need to change this denominator to your LCM. And then you can combine your fractions. All right, we're going to do the same thing in example 3. So we need a common denominator here. So here's my first denominator. It is x squared minus x minus 6. I need to factor that. What does that factor into? Using the x method, what does that factor into? What adds to negative 1 multiplies to negative 6? Negative 3 and positive 2. So we have x minus 3 times x plus 2. Okay, my second denominator here is 5x plus 10. Okay, what do those two terms have in common? A 5, so factor out a 5. And you have x plus 2 remaining. Okay, so our LCM, we need the whole first term, so x minus 3 times x plus 2. Then looking at the second term, did I have a 5 from the first term? No, so I need to include a 5 in my LCM. Did I have an x plus 2 in my first term? Yes, so I don't need to rewrite it. Okay, so this is my LCM. And I need to make my denominators look like that. So I need to multiply in that version of 1. So rewriting my expression, I have x minus 1 over, I'm going to write down the factored form of this, which we already found here, of x minus 3 times x plus 2. Now I need to change this denominator to make it look like the LCM. So what do I need to multiply in? What do I need to multiply in? 5. Okay, then we have our second fraction of 4 over, again I'm going to write out the factored version of our denominator, which we already found, and that is 5 times x plus 2. Okay, to make that look like our LCM, I need an x minus 3. So I need to multiply that into the numerator and the denominator. Okay, from here I just need to multiply. So we have 5 times x minus 1 over 5 times x minus 3 times x plus 2. Then we're subtracting our 4 times x minus 3 over 5 times x minus 3 times x plus 2. Okay, so I can combine my numerators. So we have 5 times x minus 1 minus 4 times x minus 3 all over that same denominator. Okay, from here I do want to distribute. So we have 5 times x and 5 times negative 1. And we have negative 4 times x and negative 4 times negative 3. So we have 5x minus 5 minus 4x plus 12. Again, that's all over that same denominator. I did that because I knew I could combine like terms here then. So we have 5x minus 4x. 5x minus 4x is just x. And we have negative 5 plus 12. That's 7. And then we keep our denominator as is. Questions on example 3? Questions at all? All right, I'm going to